flare. These explosions of X-ray and extreme ultraviolet light blast out plasma from the sun's atmosphere in a coronal mass ejection. But what causes the solar flare to occur? To understand, we have to look at sunspots and the magnetic arches that connect them. The sunspots are powerfully magnetic, and in a sunspot group there is positive and negative spots, with the arches connected to those opposite polarities, surging plasma through them at near relativistic speeds. These sunspots are not stable, but dynamic, always growing or shrinking and constantly moving around. You can see a good example of that here. Look at how much they are morphing. Now remember, those powerful magnetic arches are moving around with them. This is how a solar flare is triggered. When the sunspots are moving around, sometimes the arches collide, and when that happens, it's like sticking a screwdriver in a light socket. There is an explosive release of the circuit energy at the point of interaction and disruption, just as Hannes Alfvén described many decades ago. The flare is electromagnetic energy, which pushes out the electrified plasma in the sun's atmosphere in a CME, coronal mass ejection. This is where I often see terminology getting confused. I have seen many articles say a solar flare is on its way to Earth. Nope, that's not correct. The flare is the energetic light blast at the sunspot group. What is on its way to Earth in the aftermath is the CME, the coronal mass ejection. So to review, solar flares occur when a magnetic field connecting different sunspots collide and interact with another one, releasing the energy within the circuit in an X-ray explosion, which then blasts out a coronal mass ejection. When that hits the Earth, it triggers a geomagnetic storm, also called a solar storm. The magnetic field does block out much of the impact, but it funnels the plasma to the polar region, exciting the auroras. Those auroras send energy towards the equator in traveling ionospheric waves, while also inducing electric currents that run through the lower atmosphere and the ground. They also push particles directly downward due to the compression of the magnetic field in Van Allen belts. In the next lesson, we will be discussing what these energies do, but for now, just remember, sunspots are magnetic, and they are connected by magnetic fields full of electrified plasma. When the sunspots move around, the fields can interact and collide, releasing a solar flare, which then can send out a coronal mass ejection, and if it hits Earth, it can trigger a geomagnetic storm and other energetic effects on our planet. I'll see you in the morning for the Daily Show. Be safe.